Today we're going to be talking about runtime performance evaluation of JavaScript applications. Basically, what that means is how does your application perform when the user is actually using it, okay? So I think we are all familiar with load time performance, and this is about optimizing your website so that it loads very fast. And I'm going to tell you a story about that. So I think about 2 years ago, I started working for a company in the US remotely, and they had this amazing React application, which was really large, about 1,000 React components. And if you don't use React, just think of it as 1,000 pages. And it was amazing, actually. And the thing that we did is we squeezed out every single form of performance we could from the load time. So basically use Webpack, make sure that no JavaScript is loaded twice, make sure that the images are optimized and stuff like that. So the application was actually loading in under 1 second. And we're like, yay, we've done it. And then we started using the application. And then the user visits a page which actually displays a calendar, and then that calendar displays like different events on 7 different days of the week. And then I began to realize that there's junk, right? So the application loaded fast, super fast. But then there was a problem. At runtime, which is when the user is actually using the application, you begin to notice that there's some junk, right? And I don't know if you've ever noticed this, but you're trying to scroll on the website, and then it's kind of hanging, right? Okay, so that was our problem. So I was like, this can't be right. What's happening on that calendar? So I went into the source code. So what we're doing is, we had 7 days on the calendar, right? So we were looping through 7 different days of the week, and then we're making an API request to fetch 7 days. That's 7 API requests. And then for each of those, we're receiving the events of those 7 days, and then we're looping through all of those events to see or categorize which specific type of event is it. And while looping, we had an array where we had to check inside those 7 events again if it's kind of a reminder or a goal setting. So we're doing about 600 loops inside that, and the application was junky. So this talk is really about how I started my performance journey with the obsession of making sure that we squeeze out performance at runtime and not only at load time. Are we together? Okay, so this graph is an exaggeration, but it kind of makes sense. So it's a comparison of low-end phones and high-end phones. So in 2010, about 50% of users that use mobile phones were using them iPhones and them Galaxies, which are high-end phones. High-end phones are basically phones that have better processors, better RAMs. And then, about the remaining 50%, if you check in Nigeria, there's smartphone now for 9K. That kind of phone that has 0.6 gig RAM. So if somebody loads their website on that phone, if somebody loads your website on that phone, it's going to be very junky. Because what did you do? You went to your laptop and you built a React application using a 16 gigabyte RAM computer, and everything was fast for you. And you knew that your life is high. And you're like, this thing is working. You put it on Google Audits, and everything was fast. But the person can't scroll because the person is on a low-end phone. And the prediction is by 2040, there are going to be more people on low-end phones because phones are now very cheap, and everybody can create a processor. Also in Nigeria, we even start making some. So what are we going to do? We are going to do our best to squeeze out as much performance as possible. Are we together? Next. Okay, so we've talked about load performance. It's at load time. And we've talked about runtime performance while the user is using the application. Yeah? Next. Okay, so why, no, back. So why is runtime performance important? This is what Facebook does, and it's really amazing. They try to retain users as much as possible. If you imagine what goes on, even just in the Facebook mobile app, it's incredible. How many of you guys watched ReactConf 2019? Okay, if you watched it, you realize that Facebook squeezed out every single drain of CSS that they could. Their old platform now uses 400 kilobytes of CSS code, the whole of Facebook, and your website is using 1 MB, and you're not feeling bad. Okay. So they were able to squeeze out that CSS, and it actually became 70 kilobytes. Why? Because they are making sure that even at runtime, the application is as performant as possible. And this CSS is not loaded at once. They actually have a way of loading CSS only when it's required. They have a way of loading JavaScript only when it's required. They have a way of loading the JavaScript to view a video only when a video is actually about to be watched. And that's amazing. So you have to kind of have this passion to be laser focused on the performance of your application in order to retain users. They visit your website, it takes 1 second to load, but for them to stay, it has to be as fast as possible, right? So it also provides a better user experience, and the more performance your application, then the better usage of device resources that your website is gonna have. So for example, if my battery is at 80%, and I visit your website and version is at 72, that's because you are using a lot of RAM, a lot of CPU on your website. Just to load a calendar like we were doing, you're making 8 API requests and you don't care. And you're just loading data and loading data, filling up the RAM of the computer or the mobile device, and you're wasting the device resources. And if the person's phone, I've actually used the website in those days and the phone just went off. Why? Because the RAM is so low. Was it your phone? Okay, next. Okay, so for us to understand how to optimize our applications at runtime, we need to understand what happens at runtime. So remember, runtime is when the user is using the application. For example, the user is typing their name in a search box, or maybe their name in the name, email, password to register. So what happens? If you've clicked on an input box, you realize that it has a blue border all of a sudden. And that's what we call, like, it's changing the style of the page. If, for example, somebody is sliding down and things are sliding from the right, it's changing the style of the page. So what does the browser actually do to change what the user is seeing as the user is using the application? It brings us to what we call the pixel pipeline. So when you write your JavaScript application, it is going to trigger styles. For example, let's say a user is using your website and they are sliding up, and then you write your JavaScript to automatically change or transform the div to slide in as the user is scrolling, right? So what you've done is that you've used JavaScript to change the style of the application. Make sense? Now, the next step that the browser has to do is calculate the geometry of the element. Now, what does this mean? If the style that you changed was actually the width, it means that the other elements that were beside that one have to shift, right? So the browser has to calculate layout. So layout is when it calculates the position of every element on the page and positions it correctly. So for example, if you trigger the width of a div or a button, all of you that you do loader, you won't leave the button alone. No, the button has to become bigger and then it has to splash before it loads. You have triggered with JavaScript, and then you've changed the style. And since the button is now bigger, everything around that button has to shift. So you've triggered layout, right? Now the button is bigger, which means it consumes more space. And if the button had a background of red, the browser has to paint the new space that you've consumed, right? So painting is when it actually renders the pixels on the screen, when it actually puts like the background color and stuff like that. And then after doing that, it needs to be able to compose all of these elements that it has calculated. That's what composite is. So all of this is what the browser does just to change the screen for the user to see. And it's in less than a split second. So first, you trigger JavaScript. It changes the style. The browser calculates layout. After calculating layout, we have the paint. And then after the paint, we have the composite, which is bringing all of this together, depending the layers and everything. Are we together? Okay, next. So, most of the time, you might not actually trigger all of the steps. For example, if you change the color of a button without changing the dimensions of the button, it's not going to trigger layouts, right? The browser will not need to calculate any geometry. So if you are building buttons loading in your website, and that button is going to be everywhere, instead of having a button that expands and splashes, which is going to trigger layout all the time the user clicks any button on your website. You probably want a button that does not expand so that it does not trigger layouts, and it only triggers pins and composite. Make sense? Yeah, so if you're building your website where it's just one person using it, and you have just one button, yeah, make the button become a boss. Who has seen that thing on Twitter? The button become a boss, let anything. But if you're building a web application like the one we were building, and we have over 1,000 components, and we want the user to use the application as fast as possible, don't put a button that is going to expand and then scatter things around it. Do you get? Okay, next. So we can also do better. We can write code that is not going to trigger layout, and it's not also going to trigger pins. It's only going to trigger composite. And this is kind of hard, because if you want to animate a button or maybe do something when the user hovers on the page, it's very difficult to do that without expanding it or changing its dimensions. So you want to make sure that your code is actually triggering style, which can be transformed, or the opacity, without triggering the two of these steps. Does it make sense? Remember, all of this is the work that the browser does to change something on the screen. It's while changing something on the screen that the user sees performance issues. So if the browser is taking too long to make the background red when the user hovers, it's because it's still going through these steps, and it's taking time. So you want to make sure that your code kind of skips as many steps as possible. Make sense? Next. Okay, so let's talk about frame rates. Now, the frame rate, FPS, frames per second, for the human eye to be able to detect what we call junk. For example, if you're scrolling and you feel like it's hooking, the browser has to render at 60 frames per second. Basically, if I see something at 40 frames per second, it's going to feel as if it's hooking. That's how our eyes have been trained, right? So we want to make sure that the browser renders at 60 frames per second for that chart that we saw. So to do that at 6 frames per second, it needs about 16 seconds to render one frame. A frame is, for now, let's just assume that a frame is like a pixel. Like everything on the screen right now is made up of small, small squares, right? So it requires about 16 milliseconds to render one of those squares, and then 60 frames per second to render everything else, right? So the browser needs about 4 or 5 seconds to do its own work, and we have 10 seconds to change it. Now, how do we know that we are performing all of our changes in 12 seconds? Now, that's what this is about. To evaluate the performance of your application at runtime, to make sure that whatever you are doing does not take more than 60 frames, does not take less than 60 frames per second to render. Okay? Next. Okay. So on the JavaScript side of things, I'm going to demo some stuff so that you can actually see how this works in the real world. And I'm probably going to demo like 1 or 2 or 3. And I'm going to be at my laptop, but don't look at me. Look at the screen. So you can go to runtimetalk.katifrantz.com if you want to follow along with the demos that I'm doing. This is my code editor. Can you guys see? Small. Hold on. Okay, so the first, if you're on my website, you'll see this, actually, exactly this. So the first application we have here is an application to find out which came first. Is it chicken or egg? So, who said egg? Okay, so we want to evaluate, there are 2 functions, right? Sort with a slow function. I don't know if you guys can see. There's 2 buttons, sort with a slow function and sort with a fast function. And our task is to evaluate which of these perform better. Now, even if we, let's just take a real world scenario. You wrote your code and everything is working fly, but you wrote it with a slow function. Now you have to measure the performance to make sure that it's performant enough to fit 60 frames per second so that if the user is on a low-end device, then it's not slow for their experience. So what do? You open your browser, and then you go to the Performance tab on your Google DevTools. And this is basically where you can record what happens as the application is rendering a specific task. So the first thing I'm going to do is hit on this record button. Now, before we do that, there's ways you can reduce the speed of your laptop so that it does not perform at high end. If you're using a 16 gig RAM computer and a 6-core CPU, you want to make sure that you simulate a mobile device by reducing the CPU speed. Make sense? Yeah, so you can do that, but I'm not going to do that now. But I'm going to click on record, and then I'm going to sort with slow function, and you see that the chicken actually came first. Then I'm going to stop the profiling. Now, if you look at the dev tools, you can see there's a yellow patch. Can you see that? So that yellow patch is actually what happens during JavaScript execution. Now, if I hover around here, you're going to see that the frames per second at that specific moment was 4 frames per second, which means that if this user was on a mobile device, the screen is not going to be interactive. If the user tries to scroll, it's going to be hanging, right? So you can actually look at how long the JavaScript function took, which is called sort slow. It took 200 milliseconds to execute, which is very high. We want to do all of this in less than 60 frames per second, right? So this is how you can look at your application. Look at how long your function is taking to evaluate and kind of evaluate it. You can even go deeper. You can look at the bottom up, which kind of evaluates like the performance of everything you did and look for the highest. Then you can look at the sort slow. I don't know if you guys can see it, but if I click here, it actually takes me to my JavaScript and shows me the part of the code that is making things very slow. So here you can see that I'm doing a loop of 1,000 elements twice and console.logging something. Now, how do you tackle this? You go back to your code, you refactor this. After refactoring, your aim is that whatever you do, it comes back down to 60 frames per second, right? So you've gone back, you've refactored your code, then you come back to your page, and then you now create a new recording. So you've written a new function, then you sort with the fast function, right? So this is our new function, and if you look everywhere, you see that there's no yellow patch, which means that the JavaScript took a very, very short amount of time to execute. And if you look at the green, green means good, right? So if you look at the green, it means that the frames per second were fine and the user did not receive any junk. Does it make sense so far? So when you're writing your JavaScript code, whether it's in React or whether it's in Vue.js or in Angular, if you write a function that does something, make sure that you come to the profiling tab, click on record, perform that action. For example, maybe it's registering the user. Then check out what is happening. How long is the JavaScript actually taking to execute? If it's taking too long, then you have to refactor that function. Make sense? Okay. So I have a second demo to show you about how to evaluate the performance of your application. So the first thing we are going to do is this application, it squares the first 1,000 numbers, and then it renders the result on the screen, right? So I'm going to click on my record, and then I'm going to click on square first 1,000 numbers. And once it's done, I'll click on stop. Okay, so look at that. We have a lot of yellow, which means it took a really long time to execute. It took, look at it, it's even red. So it took almost 400 milliseconds, but we have only 60 frames per second. So now I begin to think, what is going on in my application? Let me try to evaluate what is going on. So the first thing I do is I come to this bottom-up tab because it's going to like rank the highest things that wasted time and put them at the top, right? So if I look into this anonymous part, I'm going to see that there's a function called render and there's a function called square. So if I click through, I'm going to actually see the JavaScript file. So you can see at this part where I did box.innerHTML, it actually took 387 milliseconds to do inner HTML. How many of us have used inner HTML before? How many of us knew that it's very slow? Okay, so we're actually looking at application and seeing that this part of the code is taking a very long time to render. So what do? We try to look for a better solution. So I'm going to come to my code editor and to the second JavaScript file. And instead of setting inner HTML, I'm going to use this thing called append child. I don't know if you guys can see. Let me enlarge more. So look at what it does. Instead of setting the inner HTML, it appends the child. So this is an example of me refactoring my code for better performance. So now I come back, I refresh. I know that it's very slow at the moment, so I clear this performance. I take another performance review, square the numbers again, and then I stop. And now the JavaScript is very, very small. Look at that. Does that make sense? But if you're working on your 16 gig RAM computer, that's how you just be flying. You wouldn't know that box.innerHTML is wasting time. And if the person is on a slow mobile phone, then it's going to have junk. Does it make sense so far? So that's how you can use DevTools to evaluate and see the parts that are causing performance issues in your application. Makes sense, right? Okay, so now the second thing we are going to do is how to optimize our application by offloading long-running tasks to web workers. So how many of us have used web workers before? Okay, basically what a web worker is okay, let's say your browser is doing things. It's rendering stuff. It's displaying all the buttons. What it's doing is that it's kind of working on a single thread, on a main thread. Let's just say your computer is doing that one thing at the specific time, right? So what you want to do is kind of make another thing so that it's going to be doing that thing in the background. Meanwhile, your main thread is not being disturbed. So a web worker is basically kind of going to take that process from the main thread. So there's many use cases for offline applications, blah, blah, blah. In this case, we are going to use our web worker like a second teammate. So let's say the JavaScript in the browser is rendering everything, doing all the work. And if you click on a button, it does all the API requests. What you can do is you can create a web worker, and then while the user is using the application, then that web worker is doing other things in the background, like making API requests, getting data, and then once he has the data, then he sends it to the main JavaScript application. Does that make sense? Yeah, so think of your web worker like a teammate. If you are busy and you have other things to do, then you can call your teammate to take care of the other things that you can't do. And the web worker is going to take care of it, right? So let's see how a web worker is going to help us kind of increase the performance of our application. So I'm going to open up the web worker demo. And basically, the web worker demo is going to kind of square numbers, just like the other one. But now, the first thing we are going to do is that we are going to do it in our main application. Let me show you. So if you look at the web workers demo we have here, this is the main application here. So the square slowly takes 7 million items, and it squares each item in that array, right? Now, this might not be 7 million items in your application. It might be you rendering a calendar like I was doing in my own application, or it might be a user registering on a registration form. So this right here is heavy work, right? Sometimes you get data from your API, and you actually have to transform this data before you display it in the browser. That transformation might take a lot of time if the data is a lot. Does that make sense? So now, at the moment, what we are doing is we just put the function in our normal JavaScript application, and we are going to take the performance, evaluate it. So I'll square it. Notice that the button is frozen. The button was frozen all the while because it blocked the application, and the JavaScript is everywhere because it kind of blocked it for about 3 seconds till it was done looping over 7 million items. Does that make sense? Now, what we are going to do is, instead of looping over 7 million items in our main JavaScript application, we're going to create a web worker, and then when it's time to loop, we are going to send that data to the web worker. The web worker is going to do the loop, square everything, and then once it's done, then it's going to send the data back to us. Does that sound like a good idea? Okay. So we are going to do the same thing. I'm just going to refresh. Then I'm going to click the web worker, and you have to be very observant. So I'm going to click it, and immediately I click it, notice that it's not blocked. If you check the console, the web worker kind of, hold on, let me stop it, okay? So notice that the UI wasn't blocked. If you check the console, the web worker can exchange messages with the main application. So it's like, hey, web worker, please, can you square these numbers for me? And then the web worker is like, okay, I've received the message. And then once the web worker is done, it can send the results of the squaring operation back to the main thread. And the main difference for you to notice here is, once the user clicks on the square slowly button, the button is frozen. And the user can't do any other thing. The user can't scroll. Everything is just frozen because it's taking a long time to finish its work. But once the user clicks on the square with web worker button, then automatically that kind of becomes easier. The button immediately releases, and then the user can keep using the application while the browser is doing its, while the web worker is doing its thing. Does that make sense? Okay, so there's many other ways for you to optimize the performance of your application. There's so many. For example, when I started as a developer, interview question for CSS, what is the, like, how do you find an element n+1 to the title with non-empty and all those kind of selectors? I don't know if you've ever seen that before. Now, according to everybody, that's a smart way of doing things. I wish I had time. I would have shown you a demo. But if you do all the n+1 things to find things on your page and all those type of CSS, it actually multiplies the performance Like it slows down your application 15 times slower than using a normal class. Does that make sense? So you have to evaluate every single thing that you do in your application. Every single thing you do, you evaluate the performance tab. I know when I started, I didn't even know that tab was there. I was just doing things. But if you're working for a startup, they are going to ask you how important is performance to you. So even if you learn performance just today and tomorrow and you have an interview on Tuesday, say, oh, performance is very important to me. Very, very important. Yes. Because if you're working at Facebook, imagine, you have to squeeze out performance. You can't just go and write code. Does that make sense? All right. Thank you very much. Can I have your questions? All right. Yeah, question.
Hi, thank you very much. Jafar is my name. Thank you for the eye opener. But my question is that the web worker now. What's the difference between using this and approaching your what's it called using RxJS? With RxJS now, with RxJS you can just implement observables, wait for and make sure that.
Okay. Okay. I think I get your question. So now, RxJS, you guys have, who has used RxJS before? Who has used promises? My people. So basically, the idea of promises is you do something and you do .then, and then when the response comes back, then you use the response to do something on your page. Then you can show a loader, right? It's the same thing with RxJS. You subscribe to the HTTP request, and then once it emits an event that the response is back, then you do something. All of these things, even the waiting time, is actually happening on the main thread. What?
Can you use maybe .tab to do something else within while you're waiting for the
All
for
of
your
that
subscription
is
to
happening
come?
in the main thread. While you are waiting, does not, who is waiting? It's the main thread that is actually waiting. If you want to say something.
Do we have to worry about all this when we are doing progressive web apps?
Yes. Because your progressive web app might do a 7 million loop, right? Your progressive web app can be slow. It can be working offline, but if the user is scrolling and you have an on-scroll event, as the user is scrolling, it can still cause junk, right? So you have to worry about it no matter the type of application you're doing. A progressive web app actually uses web workers in a different way, but you would still have to use web workers in a specific way if you want to improve the performance of your application. So yeah, no matter what type of application you're using, make sure you evaluate its performance. And you need to look more into RxJS and promises and what they really do. They're actually still in the main thread, right? It's just, you're not using a set timeout. Don't worry. Like, you can meet me later and I'll explain more to you. Okay? Who else?
My name is Tamilere. I just want to quickly ask that in implementing some of these performance issues, are we not going to affect accessibility and meeting the WCAG guidelines for screen readers and other people using sites? Thank you.
Yeah, it's a very important question. So I had a discussion with an engineer a couple of days back, and he was like, accessibility and performance, which one do you choose? And we can argue about that the whole day, right? And it's kind of like, it's a really big argument. Accessibility is basically making your application usable by as many people as possible. People with, inabilities, for example, somebody who can see should still be able to use your application. That's accessibility. Performance is when it's as fast as possible. So which one is more important? And when you're building your application, you kind of have to make the comparison. So I would always say you have to be mindful of the two as a developer. You have to make sure that you are not trading performance for accessibility and vice versa. And even though everything we've demoed today has not affected accessibility in any way, but it's a good question, and you need to make sure that you are not making your application inaccessible, and you're also making sure that even if it's accessible, then it's not performance. Make sense? All right. Question? There's a question there.
I want to know, do you need to use web workers with a React app? Given React manages its own state. So it only renders when it is done with computation and you cause a change in state.
Yeah, so thank you, very good question. First of all, if you're using Create React app, the one thing that they've done that everybody is angry about is the fact that you can't create your own web workers, right? The only thing they do is generate a web worker for you when you run npm build, and then they are going to generate that web worker. You can't modify it or you can't do anything. But the recommended approach is to create your own web worker, and if you set up your own webpack config, you'll be able to do that. Now, when you set something on state, let's say you have to do a very expensive computation before you render it. Let's say you have, I don't know, 1,000 items that you have to render on the page with infinite score or something like that. You can push the work to the web worker if you're using your React app and you're the one who configured it. If you're not using Create React app, there's still ways to use a web worker in Create React app. But if you're using your own configuration, then you'll be able to create your web worker, send that work to the web worker, and then once it's done, you send the message back to React, and then you can set state, and it's going to render. Do you get? So it's kind of two completely different worlds. So the state in React is still on the main thread, just like RxJS is still on the main thread. So you want to be mindful of the computations that you do, because React can also be slow if you use it wrongly. Do you get? The basic rule of thumb, whatever you do, open up your performance tab. Is it slow? Is there too many colors? We didn't go through paint, we didn't go through layouts, we didn't go through composite. But is there too many colors? If there are too many colors, it means that there's a performance bottleneck, and you have to look into it. Make sense? Okay, one last question, just last question.
Here, I'm here. Hello.
Okay, awesome, sorry.
On React, we have service workers too. So I don't know, working with web workers and also service workers, how are we?
Am I wrong, but those are two exactly the same things?
Okay, they're the same thing. I just wanted to be sure.
Oh,
and
okay.
also sending web workers info using Redux with React. Won't it?
Okay, so this is, let me explain. When you're using your React and your Redux app, all of those things, everything is happening in the main thread. So let's say you fetch data from an API. You fetch 500 users, and you have to map through all those 500 users and kind of concatenate the first name and the last name and render the full name on the screen. Looping through 500 users is very slow. Do you get? So what you can do is, before you actually push it to the Redux store, you send it to a web worker. The web worker is going to do that while the user can still scroll and the application is not janky. And then once the response is back, you receive the response from the web worker and then you commit it to your Redux store. Do you get? So it's like whether use Angular, use Vue.js, everything is happening on that main thread. A web worker is simply creating another thread so that you can push different jobs. Make sense? All right, guys, my time is up, but my name is Frantz. How many of you have taken my Udemy courses? I'm not popular. Okay. Okay, so please see me after this if you have any other questions, and please reach out. Please come and see me to say hi, and hopefully we can have a good chat and grow each other together. Thank you very much.